Speeding up single frame rendering with our add-on for Blender can be a little bit frustrating if you don't know how it works. So this video is an explainer as to how to get the most out of our add-on for Blender. Let's dive right in. All the data you see in this video came from benchmarks I performed on a test setup which has an RTX 2070 in one PC and one laptop, an Apple Mac with an M1 chip in it, pretty much the lowest tier M1 chip that you can get. Now, why this setup? Well, it turns out this is a very common setup that happens to come with people complaining that they can't get a meaningful speed up from Crowdrender. So I wanted to emulate what these people had and try and get a speed up, and I managed to do that, and that's what I'm going to talk about for the rest of this video, as to how to get it and why that happens. So the test results show that when the PC is used as the master computer and the laptop is used to help it render, then the PC kind of renders a lot faster by itself up until a point that we hit a resolution around about 4K, and then what you'll see is the laptop actually starts to help and the render time of using both computers starts to be less than just using the PC by itself. And once we get to 16K, the difference is quite stark. It's actually a lot better to use the PC and the laptop than just using the PC by itself. One of the other things to note is how much system RAM is used in either of the two conditions. When we're using the PC just by itself, you can see how its RAM consumption gets really big when we get into the larger resolutions. Whereas with Crowdrender, the RAM doesn't grow at anywhere near the same rate. So one of the other advantages to using distributed rendering for single frame renders is if you do need large resolutions, you can save on a lot of system memory doing the render this way versus doing it on your PC. And it also happens to be faster too. So there's two benefits there. Two benefits. So the key takeaway here is that if you need performance at higher resolutions, then it makes more sense to distribute rendering for a single image, and Crowdrender becomes more useful the higher the resolution gets and possibly the higher the sample counts gets, although I haven't done benchmarking on sample counts. So drop a comment below if you want me to do that experiment. I will happily do it. So now I want to explain why at lower resolutions Crowdrender is slower. Even though you've got the extra power of another machine helping you, what exactly is it that's causing Crowdrender to render more slowly than just one machine by itself? So really quickly, this is how Crowdrender works. You have a single image, that image gets broken up into tiles, as you can see here on the screen. Each of those tiles is then rendered by one of the two computers. Now, in order to render a tile, there's a certain number of steps that have to happen, and each of those steps costs some time. Those steps are opening a new Blender process, loading the scene into memory, and then synchronizing the render. Cycles and Eevee have a phase of their rendering called synchronization, which is where things are loaded into memory ready to be rendered. Now, when you render just on one machine, all of the things I've just told you happen just once. But with Crowdrender, all of those things have to happen for every single tile. So that overhead can add up and it can eat into the savings of having an additional computer render for you. And it just so happens with the scene that we've been using, the crossover point of where it becomes more useful is when the tiles get really, really big. At that point, there is so much rendering to do that the amount of overhead that is causing a lack of performance at low resolutions doesn't really mean much anymore. This crossover point is obviously going to depend on your project and the computers that you add. So the key takeaway from this section is that overhead, from our perspective as software makers, is hard to avoid, but you can do something about it. You can optimize your scene to reduce the amount of time that it takes to synchronize. You can do things like reducing the size and number of textures, get rid of anything that you don't need in the scene. You can reduce the complexity of models that don't need to have so much poly on them. Anything you can do to reduce the size and amount of things that have to be rendered is usually a good practice. Don't go for really high resolutions if you don't need them. Don't go for really dense meshes if you don't need them. So let's talk about hardware and maybe the ideal setup next. A lot of people who've found frustration with the software have this setup where they have the faster computer as the master and then they add a slower computer to help the master with rendering. And that's exactly what we've tested, and you can see eventually you will get a speed up, but that speed up comes usually at a very high resolution or high samples. So what's the ideal situation? Well, in a world where we didn't have any overhead, this is what you get. This graph represents the theoretical maximum speed up for dividing a render between multiple computers. And it's pretty simple to read. Along the horizontal axis, we have the number of computers that you've added, and along the vertical axis, we have the reduction in time. So 1 represents the slowest, or just one computer, and you can see if we add 2, then it takes half the time. Now, obviously in real life it doesn't because of all the overhead. but the rule is fairly similar. You just have to add a little bit of a penalty to that. So you can see that after we've added another computer, now we've got 3, it's a third of the time, and so on. And what you might notice for this is the improvements are getting smaller the more computers you add. One of the things to consider when you're using distributed rendering, no matter whether it's our software or anyone else's, is that you need to make a choice of how much of a benefit are you willing to pay for. Now, if you already have all of these computers, if you had, let's just say 10 or 20 of them just lying around, great. But if you are thinking of buying them, this graph is really important because it tells you that after a certain point, you're going to be paying a lot more to get that little bonus in speed than at the beginning. The jumps are much larger when you only have 1 to 2 and then 2 to 3 computers. After that, the benefit's going to be smaller every time. Now, realistically, you might be adding computers which are newer, so a lot of artists that we work with will go out and buy the latest computer that they can possibly get their hands on. And in that case, then the graph changes a little bit. You can see that you will get a bit more of a benefit. But you're still facing the fact that every time you add another machine, even though it is faster, the benefit won't be as large, and eventually there's no more benefit. In fact, in real life, the benefits of adding lots and lots and lots of computers wear out even quicker thanks to the overhead. So, key takeaway is, be smart about how you use the software. Perhaps you might not get a massive reduction in speed by adding a laptop which doesn't have a lot of rendering power, and that kind of makes sense. If you're adding a whole new computer with another graphics card of the same strength in, then you should be getting somewhere around a reduction of half, although that does depend on how long the renderer spends loading everything versus how long it spends actually rendering. The longer that load time, the less benefit you see. But another way to use this might be in ways where if you do have a laptop and a PC, you might want to use the laptop to go and sit somewhere else so you don't have to sit next to your big workstation, which might be noisy, or you might not be inspired in that space. Take the laptop, go somewhere else, and use the big hunking workstation to do the rendering while you work on the laptop in some cozy space somewhere in your house or office. One of our users actually managed to do this remotely, so they were able to take their laptop on the road and they were able to remotely log into their network and use Crowdrender to render on their workstation, which had 4 GPUs, which meant they could do things which were quite amazing through, what was a kind of average laptop. So hopefully these give you some ideas about what to expect when you're using our software to distribute single frame rendering, and maybe some tips on how you can get the most out of it. Also, if you want us to do a similar video on animation rendering, then we'd be happy to do that. Again, just drop a comment below and we'd be more than happy to crunch the numbers. After all, we do like doing that. So until next time, see you later.